In this video tutorial, I am going over the start of the AS Pure Mathematics Edexcel OCR-A, OCR-MEIB or OCR-B-MEI, and also, AQA as well. Edexcel, AQA, OCR-A and OCR-MEIB, going over what we call, the AS Pure Maths, the algebra section for the first few chapters. So looking at solving linear equations, solving a quadratic, rearranging formula, okay, and then finding the discriminant and completing the square, okay, for GCSE maths, okay, but this is ideally obviously for ASP or maths, sorry, but this may also be appropriate for GCSE mathology and GCSE further maths, okay, AQA level 2. So question number 3, let's solve 2x plus 3 equals 9. First step, I'm going to subtract 3 on both sides to balance each side, obviously, respectively. We have 2x is equal to 9 minus 3, which is 6. So 2x is equal to 6. I don't want 2x, I just want x. So divide it both by 2, because 2x means 2 times x. Opposite of times will be to divide. These 2's cancel, that's doink, that goes. So x equals 6 halves, x is equal to 3. Okay, question number 4. Solve this obviously quadratic case, so x squared plus x minus 2 equals 0. Again, you've got 3 different options. Factorize, complete the square of the quadratic formula. Okay, I'm going to go about obviously by factorizing it. So again, it's going to be double brackets. Okay, x and x goes in the first part of the bracket because x times x, sorry guys, apologies about that. So x times x makes x squared. Okay, then here's the key. I want two numbers that add to make positive 1, and this numbers times to make minus 2. Well, that'll be plus 2 and minus 1, or minus 1 plus 2. Okay, either way is going to be fine. Okay, so either x plus 2 equals 0 or x minus 1 equals 0. That means x is equal to minus 2 for the first bracket, or x is equal to positive 1. Okay, so essentially we flip the signs for the solution for our quadratic. So the solution to my quadratic is x equals minus 2 or x equals 1. That's question 4 done, finito. Question number 5, rearrange y equals the square root of 1 over x plus 2 to make x the sum. Okay, so step 1, square both sides, because that's the opposite of square rooting. So you have y squared is equal to 1 over x minus 2. I'm now going to reciprocate both sides, so make it 1 over. So that now becomes 1 over y squared, okay, is equal to x minus 2. Last step now is I'm going to add 2 to both sides because I want to isolate and get x by itself. Okay, so we're going to have the answer of 1 over, sorry guys, so 1 over y squared plus 2 is equal to x. So therefore my answer, guys, is x is equal to 1 over y squared plus 2, or again, I can combine it into one fraction. Either answer would suffice for the examiner, as long as you're clear which one you state. Okay, plus 2. And that, guys, is how we rearrange a formula or formulae. Okay, so we do the inverse process and we try to isolate the letter by itself. Okay, question number 6 here, so slightly more tricky. Okay, question number 6 here, so let me sort of rub this out so I've got more space. Again, guys, sorry for talking, obviously a bit fast, guys. Okay, but there's a lot this year. Obviously some recap. So question number 6, consider the quadratic function f of x is equal to 2x squared plus x plus 1. So part A, so calculate the discriminant of the quadratic. Okay, 2x squared plus x plus 1 equals 0. What does this tell you about the solutions to the equation? What does it tell you about the graph of f of x? So this part, okay, is when we have b squared minus 4ac. So the discriminant is the bit inside or under the square root as part of the quadratic formula. Okay, if it's less than 0, then it has no real distinct solution, so no real roots. If it's equal to 0, then it has what we call a repeated root. And if it's greater than 0, then it has what we call 2 distinct real solutions, where it crosses the x-axis twice. Okay, so a is equal to 2, b is equal to 1, and c is equal to 1. I'm now going to substitute this here to b squared minus 4ac and see what I get. So I'm going to have b squared is going to be 1 squared, subtract 4 lots of a, so 4 lots of 2 times 1, okay? So we're going to have 1 squared here, that'll be equal to 1 minus 4 times 2 is 8, times 1 is going to be 8, so 1 minus 8 is minus 7, okay? Therefore, we have no real solutions here, because obviously it's less than 0, okay? So it has no real distinct solutions, and therefore the graph of f of x does not intersect the x-axis, so it looks something like this here, as like a rough sketch, okay? Crossing the y-axis at positive 1, okay? From this part here, from this part here, okay? The plus 1, okay? From here, okay? So it does not intersect, it does not cross the x-axis. Okay, what about part B, guys? So by completing the square, show the minimum point of f of x has the coordinates minus a quarter 7/8. Okay, so I'm going to factor out the 2. So I'm going to have 2 brackets. I'm going to have x squared plus a half x, or x over 2, or x halves. Okay, and then obviously going to close the bracket and have that plus 1. Okay, I'm now going to complete the square on this component here, okay, from GCSE Maths. So we're going to have 2, and then obviously I'm going to open up here some brackets again. So we're going to have x, and then plus half the coefficient of x, so plus half of a half, that'll be a quarter. Okay, close the brackets, and then obviously put a square there, and obviously subtract this number squared, so minus 1/16. Okay, close that bracket, and obviously put on that plus 1. Okay, I'm not going to obviously expand the brackets. I'm going to do 2 times this and then 2 times this. So I'm going to have 2 lots of x plus a quarter. Okay, all squared minus, well, that would be minus 2/16. So that would be equal to minus 1/8. And then we're adding on that 1 there. Now I can write that 1, okay, as 8/8. So plus 8/8. Okay, minus 1/8 plus 8/8 simplifies, okay, to minus 7/8, sorry, plus 7/8. Okay, so my coordinates of the turning point, or what we call the minimum point, okay, A-level maths, yeah, so it is going to be the inverse sign here. So obviously flip the sign of that, that'll be minus 1/4, and then the y coordinate is just a number at the end. So it's minus 1/4 for the x coordinate, and then the y coordinate is equal to 7/8. So as shown or as required, okay? That's part B done. Okay, so that is revising, completing the square where the coefficient of a squared is greater than 1. Okay, what about part C? So sketch here. So be sure to mark clearly the coordinates of an intersection. So again, this is like obviously like a rough sketch here. So let's just do it here roughly. Okay, so it crosses up plus 1. Okay, minimum point here will obviously be minus a quarter. Okay, let's obviously put it somewhere here. So it looks something like that. That's obviously my minimum point. So minus a quarter 7/8, and then it crosses the y-axis at 0, 1, okay, or just 1, okay. So remember, the y-axis is when x is equal to 0. If you sub in obviously x equals 0 into the quadratic, you'll get plus 1 at the end. So it crosses the y-axis at 0, 1, or just 1 on the y-axis, okay. And that is revising and going over, okay, the material for AS Pure Maths. Okay, I hope that makes sense. Okay, again, yeah, a lot of us here, topics actually, and sorry for, yeah, we're probably talking obviously a bit faster. Okay, but obviously, yeah, rewatch, yeah, as you want to need to actually, but I hope that makes sense. Any questions, any queries, yeah, put it in the comments below. Thanks so much for actually watching. Okay, like, subscribe, comment your A-level requests below, and I'll try and do as many AS Pure Maths videos. Okay, my focus here is A-level Pure Maths. Okay, and I'll come on to mechanics and stats later in the year. my focus for now is AS Pure Maths and A2 Pure Maths. Okay, so comment your topic request below. And if anyone's looking for GCSE Maths tutor, A-level Maths tutor, Key Stage 2 SATs Maths tutor, Key Stage 3 Maths, 11 plus functional skills Maths, okay, then send me a DM here or drop me an email, okay, and I'll get back to you. Okay, I've got 4 spaces left for private one-to-one tutoring. Once that goes, guys, yeah, that goes, okay, but I might be opening up, some group classes, okay, during the October half term or later in the year. Okay, thanks for watching. Take care. All the best. Okay, happy Monday evening.